Here's another interesting physics equation, but this time we don't really need to look at the question, it's kind of useless. Here's the helpful diagram I drew for you, which is way better at describing it. Well, let's begin. First, we want to figure out what time Mike's hockey is spending on the ice strip. This is dependent on the vertical component of the velocity defined as south to north. Well, Vy equals to 5 cosine x, with the definition of x in the diagram. Well, here's the time it spends on the ice. Next, we want to know how the time affects how much both hockey move to the east, or the horizontal component. For Jake's hockey, it's just 10t, it's moving towards the east already. And for Mike's hockey, we need to find the velocity in that direction, which is 5 sine x. And the distance it moves is just vxt, which is 5t sine x. To find the remaining distance between their hockey, we use d remaining equals to dx plus xm minus xj, where dx is the initial distance. Issue is, we are going to put this equation together. We see a lot of variables like dx and dy. We know that x is within 0 and pi over 2, with 0 included as it just travels vertically. Pi over 2 is not included, or it will travel parallel to the ice strip, which isn't good for us. So we can differentiate it to get the turning point. And that's how we get this new equation with dy factorized out. We know that secant x cannot be 0 because it's 1 over cosine. And cosine is never 0 because it cannot reach pi over 2. So the only 0 component of this is secant x minus 2 tangent x. Reorganizing it, we get this, simplifying 1 equals 2 sine x, and we get solve for x, which is pi over 6, as is the only value of x within 0 and pi over 2 that satisfies 1 equals to 2 sine x. Using a very simple first derivative test, we can sub x equals 0 and pi over 3, as both are on the other side of pi over 6, and we can conclude that pi over 6 is the relative maximum. So, Mike launching the hockey at a 30-degree angle is the best at maximizing horizontal distance. Alternatively, if you're like me and didn't know how to solve this at that point in time, we just graph it. And it just shows you the turning point in decimals, which is shown right there. Well, thanks for watching.